Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle. I'm here with my co-host, Gary LaRude. Our guests today are Aaron Wiesman, LTCC Product Line Manager, and Randy Cochran, Product Marketing Manager for Mimics and LTCC products, both from Mini Circuits. Welcome, guys.
Thanks, Pat.
Thank you, Pat.
So Mini Circuits has been developing LTCC products for many years, and actually you were awarded a patent a couple years ago for a novel integrated LTCC packaging technology that operates to 60 gigahertz and beyond, which is very impressive. So I thought it'd be great to explore the LTCC market further. Aaron was the inventor named on the patent, and Randy now guiding the product line marketing strategy. We definitely have the right experts with us today.
So maybe this question is for Aaron, since you were involved in the development. LTCC technology has been around for more than 40 years, certainly in the commercial market for more than 20. So I think it's probably fair to say the technology is mature. At the same time, it's been a big area of R&D for Mini Circuits. So where is the focus of your innovation?
Gary, the truth is that strictly from a ceramic substrate process perspective, none of the underlying fundamental technology has changed for decades for any of us, the LTCC component vendors. On this front, advances are being driven by employing more automated and higher precision equipment within the process. However, advances in the material science of ceramic powders and conductive paste have opened the possibility for innovation on our fronts. And maybe I can try to illustrate my point a little bit here. So at Mini Circuits, we have been able to fabricate a ceramic substrate that yields an ultra smooth surface onto which we deposit another engineering marvel, which we call the photoimaginable conductive paste. This has a much improved conductivity and gets cured selectively, once we photoilluminate it with a glass mask. So this pretty much enables the implementation of circuits with way fewer losses, featuring superb line and pitch definitions between lines. And that's really exactly what is being required to build millimeter wave components. In addition to that, I must say that the availability of such material systems, it also required a complete electrical and mechanical and even environmental characterization of the same, which in turn generated innovation in the simulation realm, since we managed to develop a multi-physics model capable of predicting the electrical performance of our components up to millimeter waves. And that included, for instance, stuff like power handling and stress related to CT mismatches. These ultimately translated into ensuring a first spin success with no need for cost iterations and engineering assets as many of our competitors may have today. And last, I have to say that we developed a patented process to conformally coat our LTCCs with a conductor, and that effectively created a fully shielded surface mount component that yields best-in-class EMI, EMC, and isolation performance. So this is truly a disruptive technology, which yields more than 100 dB stop and rejection performance in filters, for instance. I must say that I call this innovation.
Yes.
So Aaron, how are these advancements you're describing coming to bear in terms of the actual devices that you're bringing to the market?
Well, that's a great question, Pat. Thanks. This all comes down to being able to offer novel filters as surface mount devices with tiny case styles for production-friendly costs. That's all what it is. So, for instance, the availability of such material systems and simulation models and process improvements, as I mentioned previously, naturally opened the door for the implementation of novel topologies, and these were intended to deliver required performance at millimeter wave frequencies. Actually, we deployed to the market the first commercially available substrate integrated waveguide filter, SIW, and our low pass and high pass and even band pass millimeter wave components, which all employ novel distributed filter topologies. You may look at our BFCQ product subline for reference. We've also released a new subline of LTCC filters, which features more than 100 dB stop-on rejections in isolation, as I was previously mentioning. And this is really a mini circuit's proprietary technology that it is unique in the market. Various already released DFHK filters display this feature, for instance. And in addition to that, I can speak of the possibility of implementing distributed and SIW topologies in very high quality material systems, which ultimately, as we all know, translates into millimeter wave bandpass filters, which feature less than 2 dB midband insertion losses on very narrow bandwidths. We're talking about 7% bandwidths or so. So maybe the last thing that I can mention to this end is that LTCC is naturally a packaging technology. And so we're looking at employing it internally to package some of our own MMIC die intended to perform beyond 60 gigahertz.
Well, this is clearly an area where Mini Circuits has some very unique offerings, as you've identified. So maybe back to you, Randy. Where do you see these capabilities and some of the products that Aaron has described being used going forward to address market and customer needs?
Thanks, Gary. It's important from a customer perspective for several reasons, right? LTCC lends itself to high density and small structures. LTCC accommodates multiple forms of passive circuits, including lumped, distributed, and cavity, or as Aaron described, our substrate integrated waveguide. LTCC makes footprints on boards smaller and smaller. Our new technology and capabilities drive LTCC towards smaller package sizes. Depending on the function needed, we can go as small as 0202. With the ultra-high stop band rejection LTCC filters, we are 1/4 the area and half the price of competing technologies for the same performance. Until recently, LTCC was predominantly used for applications below 7 gigahertz. Recent advances in materials and circuit topologies have allowed Mini Circuits to develop filters into the millimeter wave range and with bandwidths greater than 10 gigahertz. With our substrate integrated waveguide technology, we have the capability to get above 70 gigahertz. This enables Mini Circuits to service applications from VHF to E-band.
Very impressive. Well, thanks, Randy and Aaron, for talking with us about Mini Circuits LTCC capabilities and the products and the applications that you're targeting. We appreciate your time.
Thanks, Gary. Thanks, Pat.
Thank you as well.
And thanks, everyone, for joining us today. You'll always find interesting video and podcast interviews at microwavejournal.com. Check them out.